Okay, I'm going to go ahead and get started. Just to let you know that this lecture will last more than 50 minutes. I will take roll during class, so if you do have to leave at 11:50, that's fine. Just know that the rest of the video will keep going and be in your week 11 folder. It's just going to take more than 50 minutes to get through all this. Also, what I sent you, and I put in the week 11 folder, the notes for this section, I sent those to you because I'm trying to shorten it a little bit and not having to go over that so much, okay? So getting straight to the problems, on number one, we've actually done, these are all just different characteristics of rational functions, okay? And the first one, we've actually done some like this before, actually number 1 and 2. It wants us to find the domain of these rational functions. We've got x squared over 2 minus x. So remember, when you have a rational function or a fraction, the denominator can't equal 0. That makes it undefined. So we just need to realize what makes this denominator equal 0 and then leave that value out of the domain. Okay, so if I'm solving this for x, I would need to subtract the 2 from both sides. So negative x can't equal negative 2. And then divide both sides by negative 1. So x cannot equal positive 2. It's going to want you to put this in interval notation, right? And interval notation wants to talk about all the parentheses and the infinities and things, all the way from the bottom end of the number line to the top end of the number line, except positive 2. So the way you would write that is negative infinity to 2 and 2 to positive infinity. So that's everything from negative infinity to positive infinity, excluding that positive 2. Okay, number 2. The function is f of x equals 1 over x squared plus 3x minus 28. So looking at the denominator of this fraction, this denominator can't equal 0, right? I need to leave the value or values in this case that make that happen out of the domain, okay? It is quad, which means I can solve this using my quad program. Since it's x squared, this is not too bad of a factoring problem. So I'm going to solve it by factoring x and x for x squared. Numbers that multiply to give me 28 and at the same time add to give me positive 3 would be a positive 7 and a negative 4. So there's my factors. Set them equal to 0 and solve them for x. Or I guess set them equal to not equal 0. And solve them for x. So here I would have to subtract the 7 from both sides. So x cannot equal 7. And here, add the 4 to both sides. So x cannot equal positive 4. Okay, so if I write that in interval notation, I would start at negative infinity. Now, looking at your 2 answers here, remember, when you're doing interval notation, when you start at negative infinity, what's going to go in this parenthesis is the number that you would run up to first on the number line. If I start at negative infinity, I'm going to run into negative 7 first. In union with, or and, I want to include the numbers between negative 7 and 4. So that's that parenthesis. And I want to include all the numbers greater than 4. So 4 to positive infinity. So that includes all the numbers from negative infinity to positive infinity, except for that negative 7 and positive 4. Okay, number 3. This is where we're getting into new stuff. So that information that I sent you, the 8.5 notes, this is where they're going to come in handy. We're talking about vertical and horizontal asymptotes on this problem. So it gives me the function r of x equals 5 over x squared minus 36. And the first thing it's going to ask me again is for the domain. All right, so the domain says I just need to leave out the zeros of that denominator. So I need to figure out what's going to make that denominator 0. This one, again, is not too bad of a factoring problem because it's a difference of perfect squares. So x and x gives you x squared. 6 and 6 gives you 36. Now remember, when you're factoring difference of perfect squares, the signs are always opposites. So there is your factors when you set them equal to 0, or I guess not equal 0, and solve them for x. So here, subtract the 6 from both sides. So x cannot equal -6. And here, if I add the 6 to both sides, x can also not equal +6. So 6 and -6 need to be left out of the domain. So from -infinity, I would run up on -6 first, in union with all the numbers in between, so -6 to 6, in union with all the numbers above +6, so from 6 to infinity. So there is the domain. Oh, I didn't even ask for domain. It just asked for asymptotes. Just leave that part out. Okay, it's still beneficial. We're still going to be using things like this. This problem didn't ask for the domain. It wants to know what is the vertical asymptote or asymptotes. So this is where that sheet is going to come in handy. Vertical asymptotes also come from zeros of your denominator, as long as they are not also zeros of your numerator. What vertical asymptotes are going to be these dashed vertical lines that are going through the graph of the rational function, that the rational function, if this is the dashed vertical line, the rational function comes right up next to it, but doesn't cross it. Okay, so they come from the zeros of the denominator, which are -6 and +6. As long as they're not also zeros of the numerator. The numerator actually doesn't have any zeros, right? Because it doesn't have any x's. So the vertical asymptotes are x equals -6 and +6. So there will be vertical dashed lines on this graph at +6 and -6 that the graph will not cross. So that's how you find the vertical asymptotes, just from the zeros of the denominator. The horizontal asymptote has a chart. And I put this chart on your 8.5 notes that you should have received, and they're in the week 11 content folder. The chart has to do with how to find the horizontal asymptote. So it's the same kind of thing. It's a dashed line that goes left to right. Okay, now, where you find the horizontal asymptote has to do with the degree of the numerator and the denominator. There's 3 different options. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is automatically, y equals 0. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. degree of the numerator equals the degree of the denominator, your horizontal asymptote will be at y equals the leading coefficient of the numerator over the leading coefficient of the denominator. Okay, so that's kind of an abbreviated version of what I sent you. So let's look at this. Which of these three categories does this one fall into? The degree of the numerator is 0, right? It doesn't even have an x to the first power. When you're talking about the degree, you're trying to find, that's the term that has the highest exponent. That's going to be its degree. So the degree of the numerator is 0. The degree of the denominator is 2. Which means the numerator's degree is less than the denominator's, which means its horizontal asymptote is automatically y equals 0. Okay? There is a question about the oblique asymptote, and we're not going to work any problems that have oblique asymptotes. So that is always going to be, there is no oblique asymptote. Now, picking out the graph that this goes with, let's talk about the vertical asymptotes, what that looks like. The vertical asymptotes are going to be these dotted lines or dashed lines that go at x equals -6 and +6. The horizontal asymptote is a dashed line at y equals 0, which is actually the x-axis right here. That's where y equals 0. So when I'm looking at these graphs, that's the first thing I'm going to go with. First of all, I'm going to go with the vertical asymptotes. So let's look at the graphs. That one has vertical asymptotes at 6 and -6. Look, this one only has one of them. So that's why it's not B. This one has both. And this one only has one of them. So that's why it's not D. So it's either A or C. They both have those vertical asymptotes at 6 and -6. So now go to your horizontal asymptote, which looks like this horizontal line. When you're looking at A and C, you have to look really close, but they both have that dashed line at y equals 0. So even though it didn't ask me anything else about this graph in the actual problem, you're going to need another distinguishing feature to be able to go to the multiple choice and pick it out. The other thing that is the easiest thing to find of a rational function is its y-intercept. The y-intercept comes in if you replace all the x's in the function with 0, right? That's what makes you a y-intercept, is if your x is 0. So if I replace this x right here with 0, it essentially just knocks that out, right? Because 0 squared is 0. So it knocks that out. So what are you left with if you replace that x with 0? 5 over -36. So if I think about that y-intercept, remember your y-intercept is actually an ordered pair, right? And your x is 0, because that's what I replaced the x with, which was 0. That's what knocked that out. So this right here, -5 over 36, is the y-intercept, which tells you where this graph should cross the y-axis. So again, the ones that had the right vertical asymptotes were A and C. Look where A crosses the y-axis. Do you see that it's in the positive area? That's what makes it not be A. Look where C crosses the y-axis, right there in the negative area. So that's what makes it that C. Okay, let's look at number 4 through 9. Are all finding where the vertical asymptotes are. So again, if you look at your notes that I sent you for 8.5, vertical asymptotes are always the zeros of the denominator, as long as they are not also zeros of the numerator. So let's look at these next few problems, finding the vertical asymptotes, which means we're going to find zeros of the denominator. Number 4, f of x equals 1 over x minus 4 squared. There's actually only one zero of the denominator, because if you wrote that out, it'd be x minus 4, and that's just going to create the same answer, right? So the zero of the denominator, set it equal to 0 and solve it. So I'll just add the 4 to both sides. So x equals 4. And once again, this is only a vertical asymptote if it's not also a 0 of the numerator. Your numerator, unless it has an x up here, you don't have to worry about it. X's are what creates zeros. So I don't have to worry about there being a 0 up here since there is no x. So that is your vertical asymptote. Right, number 5. F of x equals x minus 9 over x squared plus 8x finding the vertical asymptote. So I need to find the zeros of the denominator. What makes that denominator equal 0? So again, this one's actually going to have 2 of them, right? That's what the x squared is telling me, which means I could also put that in quad. That'll solve that. It's not, again, it's not a hard factoring situation. They both just have that x that you can pull out. And put in parentheses what is left, which would be x plus 8. So here's your 2 factors. Set them both equal to 0. X equals 0 and x plus 8 equals 0. Solve them for x. So this one's already solved. X equals 0. Here I just need to subtract the 8's from both sides. So x equals negative 8. So there's the 2 zeros of the denominator. I just need to double check and make sure that 0 or negative 8, neither one are also zeros of the numerator. Here's my numerator. It is going to have a 0 because it does have an x, but it's not going to be negative or 8 or 0, right? You're not going to solve this and get a negative 8 or a 0. So both of these are true vertical asymptotes. All right, number 6. F of x equals x minus 6 over 3 minus x. Vertical asymptote, so set the denominator equal to 0. Solve it for x. So here, subtract 3 from both sides. So negative x equals negative 3. Solve both, or excuse me, divide both sides by that negative 1 to change that sign. So x equals positive 3. Looking at my numerator, again, it's going to create a 0 because it has an x, but it's not going to be 3, right? So that means, yes, that is a vertical asymptote. Right, moving right along. Number 7. f of x equals 2 over x plus 5, x minus 3. So they were nice enough and they already factored the bottom, right? It would have started off x squared and then I would have had to do my own factoring or put it in quad, but it's already done for me. There's my two factors that are going to create my vertical asymptote. So here, x plus 5 equals 0 and x minus 3 equals 0. And solve them for x. So subtract 5's here. So x equals -5 and add the 3 here. So x also equals 3. So -5 and 3 are the zeros of the denominator. Again, you do have to double check. The numerator's not going to have any zeros though, because it doesn't have an x. So those are both vertical asymptotes. Right, number 8. The function is f of x equals x squared plus 4x minus 21 over x squared minus 3x minus 18. Finding the zeros. I could factor both of those. That actually wouldn't take that long. They're not too hard of factoring, but just to show you, since they are both x squareds, I can put those both. I need to find the zeros of both, right? Because if they have the same zero, they would cancel each other and not make a vertical asymptote. So I could just go to my quad program. I'll find the zeros of the denominator first, because that's the ones that are going to make the vertical asymptotes. So let's see, my A, B, and C would be 1, -3, and -18. So A, B, and C are 1, -3, and -18. So the zeros of the denominator are 6 and -3. So there's the zeros of that denominator. Now, just to be sure, which means those are going to be vertical asymptotes, unless one of those numbers is also a zero of the numerator. So just to double check, find the zeros of the numerator, and it's quad, which means I can type in its A, B, and C, which is 1, 4, and -21. So there's its zeros, 3 and -7. So there are no zeros that are the same in the top and the bottom, which means these are both vertical asymptotes at x equals 6 and -3. Now, be careful on that one also. Look at these. Look at the difference between A and D. They're both 6 and -3, but look at these. These are y equals. Vertical asymptotes always come in the form x equals a number. X equals a number is what makes a vertical line. All right, number 9. This is my last only vertical asymptote problem. I've got g of x equals x to the third over 2x to the third minus x squared minus 10x. And I want to find its vertical asymptotes. Now, first of all, look, this was x to the third, which means there's a maximum of 3 numbers that would make that 0. Okay, I also can't put it in quad because it's x to the third and not x squared. But look what they all do have. They all have x in them, so I can pull an x out. They have a greatest common factor of x. So if I pull the x out and put in the parentheses what's left, which means divide those all by x, aren't they all just essentially going to lose an x? So let's see, what would it make this first term? Since it was x cubed, but I pulled out an x, now I just have 2x squared minus, if I took an x out of the x squared, I still have an x, minus, if I took the x out of that last term, I have a 10. Now, this is a factor. I do need to set it equal to 0 and solve it. It's just that when you set x equal to 0, it is solved, right? X equals 0. Now, this is where my other two zeros are going to come from, and now this is quad. So the fastest way to get to that is to just go back to your quad and type in the A, B, and C. So let's see, what's in front of x squared now? That 2 is. What's in front of x? Negative 1 is in front of x, so your B is negative 1. Your constant is negative 10. I'm going to get a weird decimal, so just hit enter again. Those are your other two zeros, 5 halves and negative 2. So 0, 5 halves, and negative 2 are your zeros. So 0, 5 halves, and negative 2 are the three zeros of the denominator, but what's the 0 of this numerator? What number, if I plugged it in for this x and then cubed it, would still be 0? 0, right? 0 cubed is 0. So 0 is also a 0 of the numerator, which means it doesn't make a vertical asymptote because those cancel each other. So this actually only has the two vertical asymptotes. The vertical asymptotes are at x equals 5 halves and x equals negative 2. So that's why that statement that is in the definition of a vertical asymptote is there. Your vertical asymptotes only come from the zeros of the denominator as long as they're not also zeros of the numerator. All right, 10, 11, and 12 are strictly horizontal asymptote problems, so you're going to want to have that chart handy. The horizontal asymptote problems deal with the degree of the numerator and the denominator. So let's look at number 10. F of x equals 5x cubed plus 2 over 2x cubed minus 5. So referring to my horizontal asymptote chart, the degree of the numerator is equal to the degree of the denominator. They are both degree 3, right? Because the degree is just whatever the highest exponent is. If that is the case, what does that tell you about your horizontal asymptote? If your degrees are equal, this number right here is telling you where your horizontal asymptote is, the leading coefficient of the top over the leading coefficient of the bottom. And remember, horizontal asymptotes are lines that look like this, horizontal, straight left to right, which means they come in the form y equals a number, and this is the number, 5 over 2. Again, if your degrees are the same, your horizontal asymptote is y equals the leading coefficient of the top over the leading coefficient of the bottom. right? Number 11. F of x equals x squared minus 3 over 4x to the 4th plus 7. So let's look at their degrees. Numerator's degree is 2. Denominator's degree is 4. So the numerator's is less than the denominator, which means your horizontal asymptote is automatically y equals 0 for anybody that falls into the category where the numerator's degree is less than the denominator's, y equals 0. And number 12. X cubed minus 5x squared, plus x minus 3 over x squared minus 12. So this time the degree of the numerator is greater than the degree of the denominator. So if you're looking at your horizontal asymptote cheat sheet, when the top degree is greater than the bottom degree, there is no horizontal asymptote. Okay, the rest of the problems are tying it all together, including x-intercepts, y-intercepts, horizontal asymptotes, vertical asymptotes, and domain. Okay, so if you notice, almost everything except the horizontal asymptote has something to do with the zeros of the numerator and denominator. So on every single one of these problems to the end, that's what I'm going to find first, is the zero or zeros of the numerator and denominator. So let's look at number 13. F of x equals 3x plus 3 over x. So like I said, before I do anything else, I'm going to find the zeros of the numerator and denominator. So let's see, if I set this one equal to 0, so 3x plus 3 equals 0, and solve it for x. I'm working on finding the 0 of the numerator. So I'll subtract 3 from both sides. So 3x equals negative 3. Divide both sides by 3. So x equals negative 1. So the zeros, or 0 of the numerator is negative 1. So I'm just going to keep track of that over there, what the zeros are. Now I'm going to find the 0 of the denominator. When I set it equal to 0 and solve it, it's already solved, right? So the 0 of the denominator is 0. So let's see what it's going to ask me now. The first thing it's always going to ask you is the domain. Now, remember, finding the domain just means if you have a rational function, the 0, this is why I do this on the front end, the 0 of the denominator just needs to be omitted from your domain. So my domain is all the numbers from negative infinity to positive infinity, except for 0. So negative infinity to 0 in union with 0 to infinity. Then this one actually doesn't ask for asymptotes. It wants the x-intercept and the y-intercept. Now, your cheat sheet on x-intercepts says the x-intercept is going to come from the 0 of the numerator as long as it's not a 0 of the denominator, right? Because what does the x-intercept tell you about a graph? It tells you where it crosses or touches the x-axis, right? So that's why I can't use any zeros of the denominator, because those aren't in the domain. Those 0 is this right here. That's telling me the graph is not going to go through 0. So that's why we're using zeros of the numerator, as long as they're not also zeros of the denominator. So the 0 of the numerator is -1. It's not a 0 of the denominator, which means -1 is where the graph crosses the x-axis. Now, x-intercept is a physical point, right? Which means it has an x-coordinate and a y-coordinate like all other points. The x-coordinate is that number there. The y-coordinate is 0. The last part of this problem wants to know, where is the y-intercept? Where is it going to cross the y-axis if it does? The y-intercept comes if you replace all of the x's in the problem with zeros, right? Because that's what makes you a y-intercept, is if your x-coordinate is 0. But what happens in this problem? If I replace these x's with 0, I will have 3 times 0 plus 3 over, if I replace this x with a 0, it makes my denominator 0. So that messes this up, right? If you have a denominator of 0, that's undefined. So if in the process of replacing all your x's with zeros like we've done here, if it turns your denominator into 0, that just means there is no y-intercept. You're not going to be able to put a point here, right? If I went ahead and went on with this, 3 times 0 is 0 plus 3, so 3 over 0. Where are you going to put that point? What is 3 over 0? It's undefined. You can't go put a point there because that's not a defined number. So that's why if your denominator turns into a 0, it just means there is no y-intercept. So when I am looking at these graphs, the first thing I would do is say, okay, which one crosses the x-axis at -1? So on these, you are for sure going to want to use the little magnifying glasses next to the graphs. Let's look at A. Where does it cross the x-axis? I can't tell for sure, but I can tell, since it's to the right of the origin, that it's positive, which means it's not -1, so it's not A. B is hard to tell. It looks like it goes right through the origin, but again, it's hard to tell. Let's look at C. C crosses through the x-axis a little bit to the right of the origin, so that's why it's not C. D crosses through a little bit to the left of the origin, which makes it -1. Now, if I did want to double check that, okay, because it's hard to tell on B. It does look like it doesn't cross through with the negative, but you could go and find the horizontal and vertical asymptotes of this one. Okay, we're going to do so there on the next ones. It's going to ask me all of it, so you'll see what I'm talking about. All right, let's go to number 14. F of x equals x plus 8 over x squared minus 64. So the first thing I'm going to do before I do anything else, before I even start reading what it's all, everything it's wanting me to do, is find the zeros of the top and the bottom. Put them over here. So let's find the 0 of the numerator. Let's see, I have x plus 8 equals 0. Solve it for x, so subtract the 8 from both sides. So x equals -8. So -8 is the 0 of the numerator. Now let's do the denominator. X squared minus 64 equals 0. So this one can have a maximum of 2 zeros, right? Because it's x squared. I can go to quad and put that in. If you do that, just make sure that your A is 1. Your B, since there's not an x, so there's no number in front of x, your B would be 0. And your C would be -64. Okay? I'm just going to do this factoring because I see it's a simple difference of squares. X and x for x squared, 8 and 8 for 64. One positive, one negative. And then set them equal to 0. And solve them for x. So here, if I subtract 8s, I get x equals -8. And here, if I add 8s, I get x equals +8. So there's your zeros of your denominator. -8 and +8. This right here should send a red flag. They have a 0 in common. Now I'm going to use those to help me answer most of the problem. So let's see, the first thing it's going to ask me is, what is the domain of this function? Okay, remember, where do you go for domain? Zeros of the denominator and leave those out. So the domain is everything on the number line from -infinity to +infinity except for -8 and 8. So -infinity to -8, that's all the numbers below -8, in union with all the numbers in between them, in union with all the numbers above 8, so 8 to infinity. So there's the domain. The next thing it's going to want is your X-intercept and Y-intercept. Again, going to your cheat sheet, the X-intercept are zeros of the numerator as long as they are not zeros of the denominator. So this would say that -8 is going to cross through the x-axis at -8, but this says, no, it doesn't, right? That's also a 0 in the denominator. The graph doesn't go through -8 or 8, which means it can't cross the x at -8. Those are not part of your graph, right? They're not part of the domain, which means even though there is a 0 in the numerator, it's also a 0 at the denominator, which means there is no x-intercept. The y-intercept comes, you can pretty much, when you're finding y-intercept, just cover up all your x's, right? Because the y-intercept comes, if you replace all those x's with zeros, those are just going to disappear. So what are you left with? +8 over -64. Now remember, your x and y intercepts are ordered pairs with an x coordinate and a y coordinate. What's the x? What did you put in the x? 0. Just reduce this, right? A positive over a negative is just going to make it -8 over 64 reduces to 1/8. So there's your y-intercept. And the last thing it's going to ask you about the graphs are their vertical asymptotes and their horizontal asymptotes. Now remember, vertical asymptotes, this is why you find the zeros at the beginning, are occur at zeros of the denominator, as long as they're not already zeros of the numerator, which means those cancel each other. The only vertical asymptote is 8, or x equals 8. And the last part part is talking about the horizontal asymptote, which is your degree part. So the degree of the numerator is 1. The degree of the denominator is 2, which means the degree of the top is less than the degree of the bottom, which automatically makes your horizontal asymptote y equals 0. Okay, the last part of these problems is going to ask you about the oblique asymptote. None of them are going to have one. So when I'm coming to my multiple choice, this is always, for my opinion, the first thing I go to is my vertical asymptotes. There should only be one vertical asymptote at positive 8. So look here at A and C. They both have 2 vertical asymptotes. They have 2 of those dashed lines going up and down. So that's why it's not A or C. Look at B's. Where is it at? B's is over here at -8. D's is the vertical asymptote at positive 8. Okay? All right, number 15. And there is 17 of these. So I am going, like I said, I am going to go over. I have taken rolls. So if you do have to leave at 11:50, that's fine. But I will go ahead and tell you there's something on 17 that we haven't seen yet, and it's not in your notes. So if you can stay, I'm not going to go too far over, but if you can stay, that's going to give you the explanation on that. All right, x squared plus x minus 12 over x squared plus 6x plus 8. Okay, let's find the zeros first. They're both quad, so I'm going to cheat and just use my quad program to find the zeros of the top and the bottom. So let's see, my A up top is 1. My B is also positive 1. And my C down there at the end, the constant is -12. So there's the zeros of the numerator, 3 and -4. Now do the denominator. Again, it's quad, so just go back to your quad. A, B, and C are 1, 6, and 8. So there's the zeros of the denominator, -2 and -4. Right, so the first thing it's going to ask again is the domain. Now, we just want to include all the numbers from negative to positive infinity except for those, the zeros of the denominator. So let's see, I'd start at -infinity. Now, when I'm coming up the number line, I'm actually going to run into -4 first, right? So that's what needs to be in my first parenthesis. You'll come up all the numbers below -4 and the numbers between -4 and -2 and all the numbers above -2. So -2 to infinity. So there's your domain. X-intercept and Y-intercept. Remember, X-intercepts come from the zeros of the numerator that are not also zeros of the denominator. So this -4 cancels that one, which means -4 is not an X-intercept, only the 3 is. So your X-intercept is at 3, 0. Your Y-intercept means essentially just go cover up every term that has an X, because if you put in zeros in all those terms, you're just going to knock them out. So if I cover up all those numbers, I'm left with -12 over 8, which reduces, right? 4 goes into both of those. So it'll reduce to -3 over 2. So your y-intercept is at 0, negative 3/2. Vertical asymptotes, zeros of the denominator, as long as they're not zeros of the numerator. So again, the -4s cancel each other out. The -2 is the only place you have a horizontal asymptote. So x equals -2. Did I say horizontal? I meant vertical. The horizontal asymptote, my degrees are the same. When your degrees are the same, the leading coefficients, the top over the bottom, is where your horizontal asymptote is. So 1/1, which is just 1. So you have a horizontal asymptote at y equals 1. So picking out my graph, again, the first thing I'm going to do is go find the ones that have the correct vertical asymptote, which is -2. So let's see. A, its vertical asymptote is +2, so is B. But C and D both have the right vertical asymptote, right? They both have it at -2. So after that narrowed it down to C or D. Let's see if this helps me. The horizontal one should be at +1. Look at C's. I can't tell exactly where it is, but I can tell it's negative, right? Because it's down below the origin. This one is at +1. So it's got the vertical asymptote at -2 and the horizontal asymptote at +1. All right, 2 more. I probably just need 5 more minutes. Maybe 6. The function is f of x equals x minus 7 over x plus 1. Find your zeros. They're both just going to have 1, right? They're not x squareds or cubes or anything. If I set that equal to 0 and solve it for x, it would end up being x equals 7. So there's the 0 of the numerator. If I set that equal to 0 and solved it for x, I'd have to subtract the 1 from both sides and end up with x equals -1. So there's the 0 of the denominator. The domain. Exclude the 0 from the denominator, which is just -1. So -infinity to -1 and -1 to infinity. X-intercept and Y-intercept. X-intercepts are zeros of the numerator, as long as they're not also zeros of the denominator, which it's not. So this is the X-intercept, +7. Remember, you got to enter it as an ordered pair with an x-coordinate and a y-coordinate. Its x-coordinate is 7. Its y would be 0. The y-intercept means essentially just cover up your x's. What's left? -7 over 1, which is -7. That's your y-intercept. Vertical asymptotes. Again, back to the zeros. Zeros of the denominator, as long as they're not also zeros of the numerator, which it's not. So your vertical asymptote is x equals -1. Your horizontal asymptote, since the degrees are the same, the horizontal asymptote is going to be y equals the top's leading coefficient over the bottoms, which is 1/1, which would just be 1, right? So let's go to the graphs. Look at your vertical asymptote, -1, which is going to knock out 2 of them for me. Look at A's. It's at +1. Look at D's. It's at +1. So the only ones that have vertical asymptotes at -1 are B and C. So go to your horizontal one. It should be above the origin, right? At +1. Look at that one. That horizontal asymptote is below the origin, and that one's above. So that's why it's C. All right, last one. This one's one that has a trick in it. So you may want to add a little, if you printed off that cheat sheet that I sent you, you're going to want to add something to the bottom of it called a hole. That's going to be the distinguishing feature on this one. So x squared plus 3x over 3x cubed minus 8x squared minus 3x. Let's find the zeros. This one's quad. So I'll just put it in my quad program. So A is the number in front of x squared, which would be 1. B is the number in front of x, which would be 3. Since there's not a constant and you do have to put in a number for C, it's 0. So there's the zeros of the numerator, 0 and -3. Now the denominator is not quad. It's going to have a maximum of 3 zeros. But just like the one previously that was x to the 3rd, they do all have x's, which helps us because we can take that x out. So they all going to lose an x. So 3x squared minus 8x minus 3 is what would be left. This is a factor, so it does create your first 0. Now this is quad, so I can find the other 2 zeros using my quad. So let's see, A is 3, B is -8, and C is -3. Hit enter twice. So your other 2 zeros are 3 and -1/3. So the denominator has zeros of 0, 3, and -1/3. All right, this one's domain part doesn't make you write it in interval notation. It's actually multiple choice, and it's just saying what can x not be. Well, x cannot be any of the zeros of the domain. It can't be 0, it can't be 3, and it can't be -1/3. This one kind of goes backwards. Then it wants the vertical asymptotes. Vertical asymptotes occur at zeros of the denominator, as long as they're not zeros of the numerator. So the 0 is canceled. So my vertical asymptotes are at 3 and -1/3. Then the horizontal asymptote. So look at your degrees. The degree at the top is 2. The degree at the bottom is 3. Okay, which means your horizontal asymptote, when your degree at the top is less than the degree of the bottom, it's automatically y equals 0. And then it goes to the X-intercept and Y-intercept. The X-intercept occurs at zeros of the numerator that are not zeros of the denominator. So the only one is -3. The Y-intercept occurs when You replace all the x's with zeros. What's going to be left in the top if you replace those x's with 0? 0. What's going to be left in the bottom if you replace all of those x's with zeros? 0. You cannot put a point there, right? 0 over 0 is not 0. The 0 in the denominator makes it undefined, which means there is no y-intercept. Okay? Now, when you go to your graphs, the horizontal and vertical asymptotes on all 4 graphs are correct. So then I'm going to go, because they're all at 3 and -1/3, and the horizontal one is all at y = 0. So those are all correct. Then I'm going to go to my x-intercept. It crosses the x-axis at -3. And it's hard. It's going to be hard to tell on those also. I mean, they may all either cross it or touch it at -3. It's all going to be close. Okay. Here's a distinguishing feature. There is no y-intercept. Look at A. A crosses the y-axis right where my finger is. B doesn't cross the y-axis. Look what happens when it gets to the y-axis. It puts a little hole right there. So that's okay. This one, sorry, I'm trying to see it at the same time. So this one crosses the y-axis up here. When this one crosses the y-axis, it also makes a hole. So B and D, neither one cross the y-axis. When they get to the y-axis, they make a hole. So that's the last thing we need to talk about before I'm done. Oh, I should have messed that up. The hole occurs when you do have a common 0 in the numerator and the denominator. The hole is a point where it just kind of discontinues and then starts back on the other side of the hole. The x coordinate of that point is whatever the common 0 is. The common 0 is actually 0. That's just coincidence. The y coordinate comes when so what's happening up here is I'm going to pull the x out up here, right? Which would have left me with x plus 3. So when I'm looking at these and I'm talking about graphing these, this x actually cancels that x, which creates the hole, which also creates the reason there's not an x-intercept there and there's not a vertical asymptote there. So the way you find the other part of this hole is whatever the x coordinate of it is, after you cancel, put that number in the remaining x's. So up top, I have x plus 3. So if I replace its x with a 0, I have 0 plus 3. What's left in the bottom after you take out its x? This. So if I replace its x's with zeros, I'll have 3 times 0 squared minus 8 times 0 minus 3. So what's left up top is 3. Those are all just going to go away, right? So what's left in the bottom is -3. So I've got +3 over -3, which is -1. That's the y coordinate of the hole. So there's a hole in this graph at 0, -1. So what did I narrow it down to? B and D. Look where D's hole is. It's at 0, +1. Look where B's hole is. There it's at -1. So that is the distinguishing feature, is where its hole is. Okay, so again, I'm just going to say that one more time. The hole, the x coordinate of the hole is whatever the common zero was. This coincidentally, the common zero was a zero. To find, so it's kind of like whatever made that zero, which was these x's, they cancel each other. So you're really just left with x plus 3 over 3x squared minus 8x minus 3. So to find the y coordinate of that whole, whatever your x was, replace those x's with that number. It just happened to be 0 this time. But if I put zeros there, all that's left is 3 over -3, which is -1. That gives you the y coordinate of the whole. Okay, I know that's a lot. And I did go 15 minutes over, but I wanted to get it all in on one video so we don't have to carry this over to Monday. So if there's not any questions, y'all have a great weekend.